Today we're going to for true to form forms of quadratic functions. Let's take a look at the warm-up. Okay, identify the axis of symmetry of each quadratic function. So we're going to go to Desmos. I'm going to graph -4 parentheses x minus 3 squared plus 2. I want to press the home key, and there is my axis of symmetry. X equals 3. Okay, let's take a look at number 2. So then that's 2 parentheses x plus 5 parentheses x minus 7. Now I need to zoom out apparently, probably up. And then, so my axis symmetry is x equals 1. Okay, student works 3, so go ahead and do that. All right, let's take a look at the next page. Be my one and only. Consider the family of linear functions. Use given points to sketch possible solutions. How many lines can you draw through point A? I can draw an infinite number of lines through point A. All right, let's take a look at B. How many lines can you draw through points A and B? I can draw exactly one line through points A and B. How many lines can you draw through all points A, B, and C? I cannot draw any lines through all points A, B, and C. What is the minimum number of points you need to draw a unique line? I need 2 points to draw a unique line. All right, go ahead and finish up that page. Use the given points to sketch the possible solutions. How many parabolas can you draw through point A? I can draw an infinite number of parabolas through point A. How many parabolas can you draw through points A and B? I can draw an infinite number of parabolas through points A and B. How many parabolas can you draw through all points A, B, and C? I can draw one parabola through points A, B, and C. All right, finish up that page. Activity 4.1, forms of quadratic functions. Recall that quadratic functions can be written in different forms. Standard form, f of x equals ax squared plus bx plus c, where a does not equal 0. Factored form, f of x equals a parentheses x minus r1 parentheses x minus r2, where a does not equal 0. Vertex form, f of x equals a parentheses x minus h squared plus k, where a does not equal 0. The graphs of quadratic functions can be described using key characteristics, x-intercepts, y-intercept, vertex, axis of symmetry, and concavity. Concavity of parabola. Describe whether a parabola opens up or down Parabola is concave up if it opens upward. A parabola is concave down if it opens downward. The forms of a quadratic function reveal different key characteristics. State the characteristics you can determine from each form. Standard form. I can determine the y-intercept and whether the parabola is concave up or concave down when the quadratic function is in standard form. Factored form. I can determine the x-intercept and whether the parabola is concave up or concave down when the quadratic function is factored form. Vertex form. I can determine the vertex, whether the parabola is concave up or concave down, and the axis of symmetry when the quadratic function is in vertex form. All right, go ahead and finish that up. All right, we're going to skip. All right, skip page 153. All right, cut out each quadratic equation and graph located on the end of the lesson, pages 167 to 170. Tape each quadratic equation and corresponding graph on page 171 and 173. Analyze the three tables located at the end of the lesson. Tape each function and its corresponding graph from question 3 in the graphs and the function section, the appropriate table on pages 171 to 173. All right, page 171. Tape A, B, and C, and then have space for the graph cut out. And let's go and answer the questions that correspond. So let's find information for graphs A, B, and C. Okay, so let's start with graph A. Okay, so 2, parentheses, x plus 1, parentheses, x plus 5. I'm going to press the home key for the graph. There's my vertex. So x equals -3. And the vertex is -3, -8. Let's go. We know it's concave up. Let's find the x-intercept and the y-intercept. So the x-intercepts are -5, 0, -1, 0. And then the y-intercept is right there, 0, 10. All right, let's go ahead and get the information for graph B. All right, and again, I'm going to press the home screen. Let's round it to 1 decimal place. So x equals -4.7. So, and then the vertex is -4.7, and that actually rounds to -1. All right, now it's concave up, and let's find the x-intercept and y-intercept. So the x-intercepts are -6.4, 0, and that actually rounds to -3, 0. Okay, and let's find the y-intercept, which is 0, 6.4. All right, let's take a look at the last graph. I'll press the home screen. All right, so our vertex is 3. And let's find the x-intercept, which in this case it's 3, 0. And then the y-intercept, we have to scroll down a little bit. and then that would be 0, negative 22.5. All right, let's take a look at the next page. All right, student works D, E, and F. So you're going to, on page 172, you're going to put D, E, and F, put the graphs, and then include your information. All right, let's take a look at the next page. All right, on page student works G, H, and I on page 173. So you're going to tape G, H, and I and your graph cutouts, and then include there. All right, let's take a look at the next page. You're going to skip page 155. You're also going to skip page 156. All right, you're going to skip part of this page, but then we need to review standard form is f of x equals ax squared plus bx plus c. Vertex form is f of x equals a parentheses x minus h squared plus k. And factored form is f of x equals a parentheses x minus r1 parentheses x minus r2. Consider the two functions shown from question 1. Identify the forms of the function given, then write the function in the other two forms if possible. If it's not possible, explain why. All right, so this is factored form, and we're going to turn it into standard form. So this becomes negative 2. We're going to FOIL. X times x is x squared. X times 4 is plus 4x. 1 times x is plus 1x. 1 times 4 is plus 4. Distribute the negative 2, so f of x, well, negative 2x squared minus 8x minus 2x minus 8. So then that's f of x equals negative 2x squared minus 10x minus 8, which is standard form. Okay, let's take a look at B. So vertex form, we're going to turn into standard form kind of the same way. That's 2 parentheses x minus 6, x minus 6 plus 5 equals 2 parentheses x squared minus 6x minus 6x plus 36 plus 5 equals 2x squared minus 12x minus 12x plus 72 plus 5. So f of x equals 2x squared minus 24x plus 77. And again, there's standard form. All right, go ahead and finish that up. Let's take a look at the next page. All right. Activity 4.3, writing a unique quadratic function. Okay. Worked example. Write the quadratic function given the vertex 5, 2 and the point 4, 9. Okay. So the vertex is h and k. The point is x, f of x. We're going to plug these into here and solve for a. And I'm going to make that a capital A. It's just easier when I do my work. Okay, so f of x is 9 equals a, we don't know, parentheses x, which is 4, minus h, which is 5, squared, plus k, which is 2. Okay, so then that's 9 equals a, parentheses 4 minus 5 is negative 1 squared plus 2. Well, negative 1 squared is just 1, so 9 equals 1a plus 2. Subtract 2 from both sides. A equals 7. Once you have the a value, you plug it back into here. So f of x equals 7, parentheses x minus h, which is 5, squared plus 2. All right, go ahead and finish that up. All right, let's take a look at the next example. All right, you can write a unique quadratic function given the roots and a point on the parabola. Write a quadratic function given the roots -2, 0, and 4, 0, and then the point 1, 6, which is x f of x. So R1 equals -2, and R2 equals 4. So we're going to plug these numbers in. So f of x is 6 equals, and we're trying to solve for a. We don't know a. X is 1 minus a -2, parentheses 1 minus 4. So then that's 6 equals a, parentheses 1 plus 2 times 1 minus 3 is -3. So 6 equals a, parentheses 3 times -3. So 6 equals -9a. Divide both sides by -9. Comes 1. So a equals -2/3. Okay, so our function f of x equals -2/3, parentheses x plus 2, x minus 4. All right, go ahead and finish that up. All right, let's take a look at the next example. All right, teacher works 3A and 3C, student works 3B. So let's take a look at 3A, okay? Now, when I see vertex and point, I think vertex form. So I think f of x equals a, parentheses x minus h squared plus k. Because I was given h, and I was given k, and I was given x, f of x. I'm going to plug these in, solve for a, and I have my equation. Okay, so let's do that. So that's 1 equals a, parentheses x minus h, which is a -3, squared plus 4. So that's 1 equals, x is -4. Make sure you plug in all the numbers into the equation. So then that's a, parentheses -4 plus 3 squared plus 4. That's 1 equals a, parentheses -1 squared plus 4. So 1 equals 1a plus 4. Subtract 4 from both sides. -3 equals a. So our equation is f of x equals -3, parentheses x minus h, which is a -3, squared plus 4. But when you subtract the negative, it becomes positive. Try to organize the work a little bit over here. All right. Now, here when I'm given 3 points, I want to use the form ax squared plus bx plus c equals f of x, where this is x1, y1, x2, y2, x3, y3. All right, so now I'm going to plug these points in here. So I have a parentheses x1, which is 2 squared, plus b times 2 plus 1c equals 1. There's my first equation. Then my second equation is a parentheses negative 1 squared plus b times negative 1 plus 1c equals negative 2. And then I have a times 3 squared plus b times 3 plus 1c equals negative 10. So I can convert this to a matrix. So that's 4, 1, 9, 2, negative 1, 3, 1, 1, 1 times A, B, C equals 1, negative 2, negative 10. And I remember that this is, I can solve this using x equals A inverse B. So I'm going to come over here. I'm going to go to Desmos. I want matrix calculator, new matrix, 3 by 3. So that's 4, 2, 1, 1, negative 1, 1, 9, 3, 1, new matrix, so 3 by 1, and that's 1, negative 2, negative 10, and I'm going to do A inverse B, so my A value equals negative 3, B equals 4, C equals 5. Now that I have A, B, and C, I plug it into here. So f of x equals negative 3x squared plus 4x plus 5. All right. Wilma says that she can write a unique quadratic function given only 2 points. Is she correct? Wilhelmina is correct only if it is given that one of the 2 points in the vertex. Otherwise, you would need a minimum of 3 points to write the quadratic function. All right, go ahead and finish up your work in the book and have a wonderful Wildcat day.